Hello, this example is going to be looking over probabilities and sample spaces in section 3.1. So up here we have our problems, down here we have our solutions. So I'm going to kind of talk through this and hopefully it makes a lot of sense to you. We're looking at whole numbers starting at 1 and less than 20. So that's going to be our whole numbers 1 all the way up through 19 since it's less than 20. We're going to let A be all the even numbers. So there we can see all the even numbers. And B, the numbers greater than 13. So 14 and up. So I list those sample sets there. And I list them in order in brackets. So I use these brackets here as you see. And I write A equals and B equals. So the probability of each event to occur is the number of favorable outcomes divided by the total. The total is 19 different values. So the probability of event A happening is going to be 9 because there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 even numbers over the total of 19. Probability of B. In B we have 6 different numbers over 19. So we write 6 over 19. A and B. The only thing that A and B share in common would be the numbers 14, 16, 18. So there's A and B. And then A or B. That's everything in A or in B. And we're missing a little bracket there, it looks like. So everything is going to be, every number listed in A or B, and we don't list them twice if they're repeats. So all those evens, then all those higher numbers. So to calculate our probability of A and B, it's all the ways we can make A and B. So 1, 2, 3, 14, 16, or 18, 3 different ways over the total of 19. Probability of A or B, it's going to be all the ways we can make that. If you count up that, you get 12 different ways over 19. Next is the complement. Complement of A is going to be everything that's not A. So we look at our total sample space and we look at A and we think, what's not an A? So A was all the even numbers. So not A would be all the odd numbers. And the probability of not A is just, there's 10 numbers there, so 10 over 19. Here we're just showing that probability of A and probability of not A, those add up to 1. Because remember, these are complements of each other. Like if probability it rains plus the probability it doesn't rain today, that must add up to 1. All right. Next is our conditional probability. So here we have a concrete example of that last lesson on conditional probability. Didn't make much sense. Here we'll try it again. So the probability of A given B. So that's the probability that we get an even number given we also grabbed a number that was bigger than 13. So to do that, that means we're only looking at the numbers bigger than 13. So we're looking here. And we want to look and find the probability that we get A also. So we need the probability of A given B. So the probability of A was the even number. So there's what? 1, 2, 3. I see 3 even numbers out of the total of 6. So there we go, 3 out of 6. But we can also calculate that using our formula. Probability of B. We already calculated that. That was 6 over 19 because there's 6 ways out of that total of 19. And the probability of A and B, we already calculated that one too, 3 out of 19. And if you take 3 over 19 divided by 6 over 19, we get 3 over 6. Next, the probability of B given A. So probability of B, so the probability that we get a number greater than 13 given we drew an even number. So we're looking at all of the even numbers, and we want to find the probability we get a number bigger than 13. So I see 1, 2, 3. So I see 3 favorable outcomes divided by the total of 9 different numbers here. So 3 out of 9 is our answer. And you could use the formula again for that if you want as well. Our next video is talking about contingency tables, and I think I'll make a separate video for that one.